So your x and y intercepts just where the line crosses the x and y axis. So here is our x-intercept, -3, 0. And then up here is our y-intercept, 0, 1. Weird point here. What's this x-intercept? I'm just going to have to eyeball it. So my x-intercept is between -1 and -2. Comma 0. And the y-intercept, 0, -1. So what's true about all intercepts? Do you have a question? It would be -2 if it was right here.
No, for number 1.
Oh, did I mess up? Oh, I did. Thank you. Everybody, this is the answer. I put a 3. It was wrong. Okay, so let's make a statement. What's true about all intercepts? An observation. What do all intercepts have in common? Okay. There's something really specific about an x or a y value. Dorian?
Either the x value or the y value is equal to 0.
Yeah, all intercepts have a 0 in their ordered pairs. Okay, you're probably noticing that, maybe not putting words to it, but yeah, all intercepts have zeros. So a lot of times, x-intercepts are actually called zeros in mathematics. It's like a synonym. A zero is an x-intercept. So let's go ahead and take that observation one step further. So all x-intercepts have the y-coordinate 0. Because it's always, to be right on the x-axis means that the y is 0, every time. So here our x-intercept, the y is 0, and our x-intercept, the y is 0. And then all y-intercepts have the x-coordinate of 0. Because if you're on the y-axis, then, the x value there is 0. So intercepts and zeros go hand in hand. If you're in an axis, you gotta be a 0 either for the x or the y. All right, so that's it for bell work. We're gonna do just some example problems, some notes in chapter. Wait a minute, looks like I skipped section 1. I thought it was unnecessary. This is a lot of review. I jumped right to section 2. So just take note, this is chapter 2-2. We're starting out with a rule about linear functions. Linear function can be written in the form of y equals mx plus b, where m and b are real numbers. So I can give you a lot more information in this. You don't have to write all of this down, but some other rules about linear functions. X is to the first power. It has that invisible exponent of 1. It's never squared. It's never to the third power. If it's a linear function, X is to the first power. There's only, the two variables, y and x. There's no extra variables. You won't see extra z's in there or anything. So it's just really basic. If it's a linear function, x is to the first power, and it's written in our slope-intercept form, y equals mx plus b. M and b are real numbers. So we just are going to start by determining if an equation is linear. So this is the same. We could rewrite this as y equals negative 3/4 x plus 8. So just take a moment. Is that equivalent? F of x is the same as y. We could put the 3/4 in x first and the 8 second. And this does look just like y equals mx plus b. So this is yes, linear. You would say that m and b are both real numbers, and x is to the first power. Okay, letter B is an example of something that is not linear. And I'm going to explain that by saying because x is in a denominator, and that kind of breaks the rule. So I don't know how many of you guys will remember your rules of exponents, but if x is in a denominator, I could write that as y equals 2x to the negative 1. Anybody remember negative exponents? Negative exponents lead to fractions. So this is the same as y equals 2 over x. So in this fraction, x doesn't have an exponent of 1. It has an exponent of negative 1. So that is not linear. Here's an example of x in the denominator. Two curves. Pretty complicated. So x can't be in a denominator and be called linear. This one just has too many variables. You got x and y together as a product, that's not linear. So no, I should write no there.
So x can't be in the denominator, so can x be in the numerator? And it could be called linear?
Yeah, must be in the numerator. Yeah. All right. The second skill, you're gonna other questions. Second skill is just rewriting them in standard form. So let's just look at these rules and see if they make any sense. So standard form. This one's called slope-intercept form. And this one's called standard form. The other one you might know is called slope form. So in standard form, A, B, and C, it should be simplified, so there shouldn't be any greatest common factors. A, B, and C should be integers. So sometimes we're going to rewrite it to clear fractions. A should be positive in standard form. And this is right out of your textbook if you just want to read and refer back to your textbook. And A and B cannot both be zero. Obviously, you have to have an X or a Y. So, so the first thing you're going to do in your assignment today is you're going to just say yes or no is something linear. The second thing you're going to do is to rewrite in standard form. So the X and the Y should be on the same side, and they should not be fractions, and the A should be positive. So when it says put into standard form, if I could write some simple directions for you, you need X and Y on the same side. And X should be positive. So it's just rewriting your equation. So if I want X and Y on the same side, you have options. You don't have to show work exactly how I would. But you know, maybe the most reasonable thing would just be to subtract the 8y here and move it to the left where X is. And I'm going to put it, right so that it's looking like X, Y, C. X and Y together. So the rule was that A and B and C should be integers and fractions are not integers. So how can we get rid of this fraction here? Negative 10. Negative 10 is going to do everything we want in one step. So I'm going to multiply both sides by 10, and that's going to get rid of the fraction. And since I want this first value to be positive, multiplying both sides by negative 10 will make it positive. So I'll put a little note here. So clear fractions, multiply both sides by the denominator. So those will cancel, making a negative 1 times negative 3, positive 3x. Negative 10, I'm going to distribute it. Times negative 8 will make this positive 80. Equal sign, negative times a negative will be a positive. As long as 80 doesn't divide by 3, that's good. Well, it divides by 1, 2, 40, 8, 5, not 3. So this is now standard form, and these rules have been adhered to. A, B, and C are integers, not fractions and not decimals. A is positive, and they can't all be divided by 3. If they could, then we'd have to reduce it. And this is what this one means. They don't have a GCF. Okay. Looks way easier. I guess we led with the most difficult one. So we want x and y on the same side, and we want the x value positive. We want x positive is what I said. The constant should be alone. The number by itself. I don't know if that answers your question. I'm going to subtract 4x and move it over here. X and y together on the same side. And so now we are much closer to standard form. But there is that little rule. A should be positive, greater than or equal to 0. So how do you guys want to get this to be a positive value? Go ahead, Torian.
Do we divide it by a negative sign?
Yeah, we could divide by -1. Go ahead. Or multiply by -1. Do the same thing. Who wants to multiply by -1? Who wants to divide both sides by -1? Okay, it's pretty much even. I'm going to be consistent with what I just did in letter A, and I'm going to multiply both sides by -1. It does the same thing. Distribute that in there. Multiply on the other side. Now we have a positive A value. 4x minus 2y equals -5. And most of you guys just know how to change every sign. You just switch every sign in the equation. And that's a good standard form. One more. Try to put that in standard form. We want it to look like this. X, Y constant in our A's and our B's just look like regular numbers. I'm gonna +9. Call it a day? No, I'm not. What's wrong with this? Go ahead, Gabby.
We share a greater common factor than 1.
Yes, look, they all divide by 3. So don't block so soon. Okay, so I added 9. I didn't show my work on the screen, sorry. To both sides. And now everything is divisible by 3. So I'm going to divide both sides by 3. Or maybe you could multiply both sides by 1/3. Same. 1x minus 2y equals 3. That's all the rules about standard form. Alright, the last skill that you need to know for chapter 2-2 is the linear function is graphing using intercepts. So we're going to find the intercepts and graph, and this is why in Bellwork I had you just identifying intercepts. So for all x-intercepts, you're going to plug in 0 for y because that x-intercepts y is 0. So it's, two parts, two-part problem. So given this equation, I'll put a 0 here, solve it out. Do it again, but I'll put the 0 here, solve it out. Go ahead and draw a picture when you get your points and actually graph it. If you don't have a ruler, you can always use the edge of your ID, and it's almost always just like right about the right length for your notebook paper. You can do that. It'd be great if you had graph paper. So I got negative 3y equals negative 8, and I divide, and I get y is 8 over 3. So 0, positive 8 over 3. So you have my permission all year. I want you to do your work in fractions, but if you want to write the decimal form down to help you, plot it, totally do that. So that's the same as 0, comma 2.67, right? So that's gonna help you maybe get your point. So the goal is to draw. So just get your intercepts, plot them, connect them, and that's what we're looking for your linear straight line graphs. Anybody have questions? Do we have anything else? Maybe one more example. One more. Are you guys so good about this? You want to just